here's our intermediate value theorem. It needs to be 1, continuous on the closed interval from A to B. 2, just like you saw in that previous video, f of A and f of B cannot be the same. Then 3, n, he used k, is any number in between f of A and f of B. So if you have a number in between f of A and f of B, and you are drawing, there is no way I can go from there to there without hitting that somewhere along the way. And that is the statement. There exists at least one number such that f of c equals n. So if we can show those three things, then common sense will prevail and something has to exist. So here's our question. X to the 5. You're not allowed your graphing calculator. You want to graph that. Does it have an x-intercept? Well, I guess we could use synthetic division and attempt to factor this, but it might not factor. Is there an x-intercept between 1 and 2? Well, first of all, it's a polynomial function, so I know it's continuous. So the three things for intermediate value theorem that we need to show. 1, we need to show that it's continuous. Check. 2, find f of 1 and find f of 2. Are they different? Yes. So 2, they're not equal to each other. And they're opposite signs. 1 is -3 and 1 is 40. And then, since 0 is in between -3 and 40, that's step number 3, by the intermediate value theorem, there has to be at least one number between 1 and 2 that makes this work out perfectly. Can someone give me an example of a number between 1 and 2? 1.5. Okay? I just want you to observe if you could factor that, which you cannot. If you could factor it, all the factors would be nice, like x plus something, x plus something, x plus something, x minus something. They'd all have to be x's to get x to the 5, right? Does that make sense? And if you have an answer between 1 and 2, that would make one of your factors like x minus 1.3. That's not a very nice number. So I can tell that there's an answer in there, even though I don't know what it is. But that could be helpful to be like, okay, now if I didn't have a calculator, I could do some like guessing and checking in between those values, see how close I could get. But I know that 1 is in there. It wouldn't make sense to guess and check anything between 1 and 2 if you didn't know for sure it was in. Does the intermediate value theorem guarantee that in that parabola it will equal 1 at least once in between -1 and 5? Justify your answer. So in order for the intermediate value theorem to work, first of all, we have to say it's continuous. All polynomial functions are continuous everywhere. Every function we've been doing so far has been continuous on its domain. So if you had a rational function, you could say this rational function is continuous on its domain, therefore it's continuous on 3 to 5, or whatever values you have. Number 2, figure out f of -1, figure out f of 5, and f of -1 doesn't equal f of 5. And since 1 is not between 0 and -18, the intermediate value theorem cannot guarantee anything. We don't know. Maybe we're on the part of the parabola that just goes straight. Maybe it does. Maybe you have part of the vertex in between them and it makes a difference. But this would not be enough to say or guarantee that it would for sure work between those values. And our last one of the day. Do it really quick. We have a rational graph. So it has a non-permissible value at 1. Is that non-permissible value in our interval that we're looking at? No. So we can say it's continuous on that interval. You can plug in 2, you can plug in 5, and you get 1 and 1/4. Is 5/6 in between 1 and 1/4? Yes. So we can say by the intermediate value theorem, it does guarantee there is a point equal to that in that interval.